Alright, in this video we're going to go over 10-1 areas of parallelograms and triangles. Yes, we skipped number 9 for now. We'll come back to it later. Alright, so here's your vocab. Base of a parallelogram or triangle can be any one of its sides. Alright, so base of a parallelogram or a triangle, it can be any one of its sides. Altitude, a segment perpendicular to the base. We've gone over altitudes before. Height is simply the length of that altitude. Alright, so make sure you write these down in your notes. These are your vocab words. You will need to know them. Alright, let's go over some formulas here. Formula I know everybody knows is an area of a rectangle. Spelled area wrong. Alright, area of a rectangle. Pretty much everybody knows that's length times width, or you can also call that height. So if we had a rectangle, and this was your length, and this was your width. Right, or, let me use height. Let me use length and height. Or base and height. So this would be your base, this would be your height. Alright, so to find your rectangle, you could just simply multiply these together. This was 3 and this was 5. You'd go 3 times 5 equals 15. 15 units squared. Alright, units squared, that would be the area of that rectangle. Now, the area of a parallelogram is the exact same formula. Area equals base times height. Alright, it's the exact same formula. Here's why. Here we have a parallelogram. So we have a parallelogram. Now, if you were to drop a perpendicular line here, cut off this triangle and move it over here, what would you have? You'd have a rectangle. Alright? So, your area for a parallelogram is the exact same area, the exact same formula as area of a rectangle. Now, that line we dropped down, that's your height, and then this would be your base. Since this line is perpendicular to this line, this would be your base. Okay, now, you can also do this the other way, which I'm going to show you an example, and where you could use this as your base, but then you'd have to have a line perpendicular to it to be your height. I'll show you an example of that later. It'll make more sense. Alright, so let's look at an example. I'm not going to do too much with area of a rectangle because I know all of y'all know that. So, here we have a parallelogram. Alright. This is 4 inches. This side is 4.5 inches. And the base here is 5 inches. Now, if you wanted to find the area of this, area, you know now, is base times height. So, here's our altitude. So we know that's our height, 4. Now you just have to find a line perpendicular to this line. Well, that's this line. What's the length of that line? 5. So what's our area? 20 inches squared. Don't forget the unit squared on the end. Alright, so there's our height. This is our base because our altitude and our base are perpendicular. So therefore, 4 is the height, 5 is the base. Multiply them together, you get 20. Let's look at another example. Alright. This is 9.4, 13, and this is 9 inches. Alright, so here we have A, B, C, D, and then this point is E, this point is F. Alright, now, I want to find the value of X, which is this altitude right here. Now, when you first look at this problem, you might say, well, we can't solve this because we don't know what that is, so we can't find the area. Well, we can. Remember how the base of a parallelogram can be any one of the sides, and then the altitude is simply a line perpendicular to that side? Well, if you look, here we have a right angle. Yes, we have one here, but we don't know the length of that altitude. But here we have a right angle as well. So that means this is our altitude right here. This 9 inches, that's our altitude. So base times height. So we can use 9 as our height because it's perpendicular to this side of the trapezoid. I'm sorry, the parallelogram. Now, since it's perpendicular to this base, the 13, even though we had to extend the side out to make it perpendicular, we can still use 9 and 13 to find the area of that parallelogram. And it's simply 13 times 9. Alright, so 13 times 9 is 117 inches squared. So now we know our area is 117 inches squared. Alright, so again, look for your right angle. This was a right angle. Well, we don't have X. This was a right angle. So this is our height. It's perpendicular to this base, so this is our base. 13 times 9, 117. So now that's the area of this trapezoid. It didn't do anything with the area of this triangle. It's just the area of this parallelogram, not trapezoid. I don't know why I'm calling it a trapezoid. Alright, so now, if we want to find X, well, we know our area still equals 117 inches squared. Well, we know that since X and the 9.4 are perpendicular, we can also use those two measurements, the 9.4 times the X, to find our area. Alright, because the area is not going to change. Regardless if you use the 13 or 9 or the 9.4 and whatever this X value is, the area is not going to change. So it's 117 for the whole thing. So now you just simply divide off the 9.4. So X equals about 12.4. Alright, so that's how you find X. Because remember, like I said, the altitude doesn't have to be inside the parallelogram. It can be outside. Alright, so from C to F, that's our altitude, and it's perpendicular to side DA. So we can use 13 as our base and 9 as our height. What we could have done is also, we could have put it inside. Right there, 9 inches. But the reason they put it outside is to make it less cluttered. Alright, and in an attempt to make it a little less confusing as well. Alright, but you can put it either place. Let me get rid of it now, out of there. So now, 13 times 9 is our area, and we wanted to find the height of this altitude. Well, we know that 117 is going to have to equal 9.4 times X, because that's our altitude and that's our base. So we know that 117 equals 9.4 times X. Divide off the 9.4. X is 124. Alright? So that's how you find the area of parallelograms. You look, basically, the first thing you need to do is look for two lines that are perpendicular to each other. Then make sure you have the length of the altitude and the corresponding base. Alright, so here we didn't have X, so we couldn't use this combo. So we had to look elsewhere. Well, we found that right angle, so we could use this combo, 9 and 13. That gave us our area, and then we simply said 9.4 times X will also give us 117, because again, it's another altitude-based combination. And then we just simply divided off the 9.4 to get 12.4. Alright? So, we'll do another problem with those in just a second. Let's move on to triangles now. The area of a triangle equals 1/2 the base times the height. So now when you have a triangle, it doesn't matter what it looks like. This is your base, this is your height. Alright? So, and the reason it's 1/2 is because if you chop this off here at the height and you mirrored it over, it boxes in this side. If you did the same thing, it boxes in that side. Then you have a rectangle. So really, all triangles are half of rectangles. Alright, they're half of rectangles. So, let's look at an example. Here we have a triangle. Alright, say this is 3, and this is 4, this is 5. What is the area of that triangle? Well, let's fill in our formula. Area equals 1/2 the base. Well, again, look for your right angle and make sure you have a base altitude combo. Here's our right angle, so we have one. This is a right triangle. So here's our base altitude combo. So we're going to do 4 times our altitude, which is 3. All right. Now, if you want to, you can go ahead and say, well, 1/2 of 4 is 2. So this is simply going to be 2 times 3, which is 6. But if you didn't do that, you'd have 1/2 times 4 times 3, which is 12. 1/2 of 12 is also 6. All right. So you can always reduce before you multiply, because there's no need to multiply up to reduce back down. All right. So let's look at another example. Here we have a triangle sitting on a square. Alright, so here we have our altitude. This is 8 inches. This is a square with a side of 6 inches. We want the area of the entire figure. Alright, we want the area of the entire figure. Well, what we need to do to start with is we need to break this into 2 shapes. The top shape's a triangle, so we need to find the area of the top triangle. The bottom shape is a square, so we need to find the area of the square. Then we're just going to add them together, and we'll have the area of the whole thing. Well, for a triangle, we know it's going to be 1/2 the base. Well, how long is this side? It's not listed. But we know this is a square, and this is 6 inches, so that means all 4 of these sides are 6 inches. So that means that the base of this is 6 times the height, which is 8. Alright? Now again, you can half either number. So that would go to a 3. 3 times 8 is 24. So the area of the triangle is 24. The area of the square, both the base and the height are 6. So that's 6 times 6, which is 36. So the area of the entire figure would be simply 24 plus 36, which is 60 inches squared. So again, when you have shapes like this, break them apart. Alright? Break it into a triangle, break it into a square. Because then once you find the areas of those individually, like we did here, you just simply add them together to get the area of the entire shape. Alright? Alright, let's go back to parallelograms, and I'm going to give you all one more problem. And I want you to try this on your own first. I'm going to give you a little bit to work on it. And then I'm going to step in. Alright, what is the area of the parallelogram? So go ahead and find the area of the parallelogram. Alright, area of a is simply base times height. So look for your right angle. Here it is. So do we have both corresponding sides? Yes, we have our altitude, we have our base. So that's simply going to be 10 times 20, which is 200. All right, it is simply 200. Now, let's look at another example. And this will be the last one. What I want you to do is find the value of x. All right, I want you to find the value of x. So here we go. All right, find the value of x. Round your answers to nearest 10. All right, so to find the area of the parallelogram, we know it's base times height. So we need to look for our right angles. Well, here's one. Well, that's x and 0.5, so we can't use that because we don't know what x is. So let's look for another right angle. Here it is. Do we have our altitude? Yes. Do we have our base? Yes. So let's use the 0.3 and the 0.4. So we're going to do 0.3 times 0.4, and that gives us 0.12. All right, that gives us 0.12. So this is our area, 0.12. Well, now to find x, we know that x and the 0.5 is a base altitude combo. So we're going to do 0.5 times x. Now divide off the 0.5. Divide off the 0.5. So x should equal 0.24. All right, 0.24. Because 0.5 times 0.24 gives us the 0.12, which is our area. So x here equals 0.24. So the main thing when you're doing area of a parallelogram is you want to look for your altitude-base combinations. You start off by looking for right angles. Here we have a right angle. So since this line, since it's dotted, we know that's the altitude. And since it's perpendicular to this side, we know this is the base. So that is an altitude-base combo. Same thing here. Since this 0.3, since this line is dotted all the way from vertex to vertex, we know that is an altitude. Then it's perpendicular to this side. So we know that 0.3 and 0.4 is another altitude-based combo. All right? So this has been your areas of parallelograms and triangles. Feel free to watch this video as much as you need to. Make sure you're ready to work some problems tomorrow. See you tomorrow.